For our physics final, we decided to analyze a knuckleball. We specifically chose to analyze a knuckleball from soccer because all group members play soccer and know what a knuckleball is. So what is a knuckleball in soccer? So a knuckleball is a shot with no spin, which can change trajectories mid-flight. The aerodynamic lift forces on the ball fluctuate and can cause a zigzag trajectory. And without spin, minimal friction will make the knuckleball keep its speed. Therefore, it doesn't speed up or slow down mid-flight. So how do you hit a knuckleball? So to hit a knuckleball, a person must hit the center of the ball with the inside of his or her foot and hit the ball in an upwards motion. This motion minimizes the torque on the ball, which is a twisting force that causes rotation, and thus by eliminating this twisting force by hitting the center of the ball, it creates the knuckle effect on the ball.
Alright, so in order to find the force behind a knuckleball, we need to use these variables here. So we have F, which stands for force, times the change in time, and then M, which stands for mass, times the change in velocity.
Okay, so in order for us to find the force, we're going to first have to find the mass times the total velocity. And we do have the weight of the ball, which is 0.43 kilograms. And we do not have the total velocity of the ball. So the initial velocity of the ball was 0 meters per second because the ball was not moving. So to find the final velocity, we did distance over time. And it was 27 yards away, so we converted that into meters, which is 24.7 meters. And how long the ball took to get to the net, it took 1.14 seconds. So we did 24.7 meters over 1.14 seconds, which got us 21.7 meters per second. Since we have found the final velocity, we got 21.7 meters per second, and the initial velocity we already have, which is 0 meters per second, which is going to equal 21.7 meters per second, and then we're going to times it with the mass of the ball, and what we got from the mass of the ball was 0.43 kilograms. So those together equals 9.331 kilograms times meters per second. And since we have the total change in time of how long the foot was in contact with the ball, which we got approximately 0.01 seconds, and because force times total change in time equals mass times total change in velocity, we're going to divide 0.01 seconds to the kilograms times meters per second, which we got 9.331 and that is going to be our force on how much force was put into the kick.